So, welcome. Wow. This is fine. This is fine. I'm all right. This is fine. This is fine. Last year, I was in a small little car accident during a trip. A speaker trip at a conference, and we hit some ice on the road, and the van skidded and hit a barrier, but it was all fine. And I was wearing a heart rate monitor at the time, and it was about 90. So this is pretty high. It's fine. It's fine. So I am wearing a Bluetooth heart rate monitor, and it is showing my heart rate straight from the monitor, the device, to the browser, using a new API called Web Bluetooth. And it works pretty good, and if I take this off, I have it here, then, well, I'm basically dead. But it's fine, it's fine. So let's start with the talk. The talk is called Fun with Bluetooth. My name is Niels Leenheer. I also tweet at HTML5test. And the first question I always get when I do this talk is why? Why would you want to connect a Bluetooth device to a browser? Now, the answer to that is basically PWAs, Progressive Web Apps. So Progressive Web Apps are great. You get offline support, you get an app-like experience, you get add to home screen, and for many things, this is a better experience for users than just a native app. Now, there is one thing that PWAs can't do. They can't talk to hardware near you, on the same network as you, or well, things like light bulbs and stuff like that. So if you have a need for talking to a device, like a light bulb, you need a native app. But I don't want to download a 500 megabyte app on my phone. And especially not now. I just arrived in Ukraine yesterday, and I got a bundle from my telecom provider for 500 megabytes for a whole, well, next couple of days. I don't want to spend it on just one app. And it already cost me more than I probably would like to pay anyway. Or the app is really crappy. It was built 5 years ago and it doesn't work anymore. It was never updated for the latest version of Android or iOS. Or I just want to use my laptop or my desktop and, instead of my phone, and the manufacturer only created a mobile app. So there are many technologies that you can use to talk to devices, but for various reasons they are not suitable for a progressive web app. They're not suitable for the web. For example, even though many devices on Wi-Fi expose a web server that you could talk to, they're often HTTP only. And good luck connecting that device to your HTTPS only progressive web app. That just won't work. But there is one technology that is ideal for your devices. It's low energy, it's cheap, and there are millions of devices already out there using this technology. And now there's a web API in the works. And it's Bluetooth. Bluetooth devices. I know. The first thing everybody says when I talk about Bluetooth is Bluetooth sucks. Yeah, it's slow, limited range, pairing. Yeah, it's a 20-year-old technology based on 20-year-old technology. or 20-year-old standard based on 20-year-old technology. But then you're thinking about classic Bluetooth. And we're not going to talk about that. We're going to talk about Bluetooth Low Energy. And that solves all of those problems. And it's actually a modern standard. Now, it's known under many names, like Bluetooth Smart or Bluetooth LE, Bluetooth 4, 5, BLE. But it's all the same thing. We're talking about Bluetooth Low Energy. If you're worried about, for example, range, that was one of the problems of classic Bluetooth, the maximum range that they managed to get this to work is more than 1 kilometer between devices. So this is not the old classic Bluetooth anymore. And 10 million devices ship every day with Bluetooth. Now that includes mobile phones, of course. All of your mobile phones are Bluetooth devices, but also computers. But also serious medical applications like glucose monitors or heart rate monitors. We have activity trackers for sport and health. We have IoT applications like light bulbs. And even toys like this cute little robot, or drones, or fidget spinners, or yeah, let's not talk about fidget spinners. But first, the boring theoretical stuff. So we have 2 types of Bluetooth devices. We have a central device and we have a peripheral. The central device is the device that talks to the peripherals. It can send commands to a peripheral. So your mobile phone is the central device, and a light bulb, for example, is the peripheral. Now, a central device can talk to multiple peripherals at the same time. So your central device, your mobile phone, can talk to a light bulb, and it can talk to a drone at the same time even, but the drone can't talk to the light bulb if it wanted to. I don't know why, but it just can't. And we're not even talking about Bluetooth Low Energy in general. We're talking about a very specific application of Bluetooth Low Energy, and it's called Generic Attribute Profile. And that has a very obvious abbreviation, GATT, because GAP was already taken. Yeah, fine. And when we're talking about GATT, we're no longer talking about central devices and peripherals anymore. We're talking about clients and servers. So your light bulb is a server. That took me some time to wrap my head around, because you don't think like a light bulb as a server. But it is. It provides a service. The service is light. So it provides a service, and you have a client, just like a browser, and that client asks something from the server, give me some light, and the light bulb gives some light. So it kind of makes sense in a weird way. Now, each of these devices, each of these servers have one or more services. In this case, a light bulb, of course, has light, but it also has some device information. And that device information, that is a standard that is built into the Bluetooth standard, and it provides some simple things like manufacturer name and model and stuff like that. And light, that is unfortunately not standardized, so every light bulb that supports Bluetooth kind of has its own thing there. We'll get into that later. Now, a drone, for example, might have device information and battery information, which are standards, and it has flight control for flying the drone, and that is not standard. And this cute little gadget, this robot, has device information again, and battery, and it has steering control, which isn't the standard. And an activity tracker might have device information, battery again, and heart rate, which is a standard. But if you buy some cheap devices, they may not have all of those. And even the heart rate is not a standard in some cases, and you have to figure out your own on yourself. If you buy a slightly more expensive one, of course, those devices all have the standard services, and they work out of the box. Now, device information. That service has multiple characteristics. Those characteristics can be simple strings or bytes that tell you something about that service. So device information may have manufacturer or model number or serial number, and those individual properties, those are the characteristics. And you can have multiple characteristics per server. So think of it as the server is like an array of objects, and the service is an object in that array. A characteristic is a property of that object, and those have values. And those values you can investigate. Now, unfortunately, unlike objects, they don't use strings as identifiers. They use UUIDs, and those are 16 or 128 bits, and they look like this. So this is device information, it's 180A. Or you have a longer version that, and I'm not going to pronounce that. Battery, that's 180F. If you have a non-standard one, you can only use the 128-bit version of the UUID and not the smaller one, because those are reserved for standards. And of course, nobody listens to the standard, and everybody uses some 16-bit UUID anyway. And so we have some clashes. But yeah, standards, who cares about standards? Now, device information. This is very clear what this does. We have device information, we have manufacturer, we know what that means. This is what it really looks like. So this is bad for readability. This is very good for saving bandwidth. And Bluetooth has very small bandwidth, limited bandwidth. So this is a very good thing. And you need to look in the standard to figure out what these numbers mean. Fine. Now, each of these characteristics can be read, they can be written to, or you can get notifications, kind of like add event listener, and when something changes, you get an event. And each value is an array of bytes. So we don't have fancy data types, we don't have strings, we don't have integers, we just have bytes, one or more bytes. And what those bytes mean are, well, sometimes defined by the standard, and if you have a device that isn't standardized, maybe the manufacturer has documentation, maybe, and otherwise you have to figure out yourself. So, phew, this was the boring theoretical part. Now the fun part. First, let's take a look at how this looks. I have an app on my phone that I can use to inspect a device. So here on this side of the screen is a light bulb. It's not really visible because it's white. But if we connect to the device and we look at it, we can get some services, like battery service. And we can see it's 90% battery. There are some custom services. Those are particularly interesting to me. And there's a whole list of characteristics there which I don't know what they do. But there's one that's particularly interesting. It has 4 bytes. It's FF0F. So if we fill that with some random bytes, well, not random, with 00FF0000, it turns kind of red. Now, if we use 0000FF00, it turns green. This is green. Okay. 000000FF. Then it turns blue. This is blue. Just trust me, this is blue. So what if we use 0000 of FF00000000, then it turns white, and you can't see that because it's already a white light bulb, but okay. So that kind of sounds like RGB values in HTML. FF0000 or FF9900, those are HTML colors. And we can send those colors to that light bulb, and the light bulb will turn that color. So this is fun, this is good. Well, no, this is still boring facts about Bluetooth. This isn't fun yet. Sorry. So instead of boring facts about Bluetooth, let's make this talk about fun with Bluetooth. Finally, that's why you're here. But first, the Web Bluetooth API. I'm sorry. The Web Bluetooth API. How do we talk to devices from the browser? Because we've seen we can connect to a device with an app, but you already knew that. How do we do this from the browser? Now, there is a new API. And using that API, we first have to connect to that device. We do that with navigator.bluetooth.requestDevice. And we provide some parameters. And for example, we say we want to have a device with a particular name. And we specify which services we are going to use. In this case, the service that we looked at just a moment ago was the FF0F service. So we're going to use that to connect to the device. Then we get a dialog box. That is a list of all the devices that adhere to the filters I've just provided. So your browser can't just go out looking in your room for devices to connect to. That doesn't work. You actually have to manually select the device in the browser, and that is because of security reasons, obviously. You don't want browsers just to start sniffing around your room and see what devices you have. So when we click on the device that we want to connect to and click pair, we get a promise back. And promises are so 2017, so let's make that async await, which is way nicer. So we await our device, and once we have our device, we can connect to the GATT server on the device. So we await our server, and with our server, we can get the primary service. We provide the service UUID again, in this case FF0F, and we await our servers. And finally, we get our characteristic, and we await that, and once we have that, we can do stuff with it. Fun stuff, finally. Like writing data, fun. Just a moment, fun, yeah. So we call write value on the characteristic with an array of bytes. And these are the bytes we've already looked at. We have 0, 0, and then R, G, and B. So this light bulb, I have it here, it has 4 LEDs in it. And each of these bytes determine the intensity of each of the 4 LEDs. So by combining the intensity, you can basically create every color you want. Okay, we write some bytes, and the light bulb turns into a particular color. Now, if we want to know the color of the light bulb from the browser, we can read data too. We can call read value on the characteristic, and then we can pull out the individual bytes again, and we have our RGB value. Now, getting notified of changes. I mentioned that is kind of like add event listener. It is actually add event listener. And you call add event listener with characteristic value change. That is a little long word, but yeah. And then you get a callback with an event, and in the event is a target and a value. And that value has some bytes for you to look into. And we have our RGB values again. Now, for a light bulb, that isn't really useful, because how many times does the color of a light bulb change, unless you tell it to? But for a heart rate monitor, this is really, really good, because your heart rate constantly changes. And instead of polling for each of these changes, you get a notification every time it changes. So again, that saves bandwidth, and bandwidth is limited. Now, what you must not forget is to actually start listening for notifications by calling stored notifications, because otherwise it doesn't work, and that's again to prevent the use of bandwidth when it isn't needed. Now, to play with this is all you need to know. The Web Bluetooth API, yeah. And I explained pretty much 95% of it. This is basically all there is to it. So this is something you can do yourself. Promises or async wait, and typed erase. Now, browser support is still a little bit sketchy, because it's basically Chrome at this time. Of course, Edge is using Chromium in its upcoming release, so that's going to support Web Bluetooth too. Finally, yeah. And Samsung Internet on Samsung phones also support it. Hi. And there are builds with Servo, which is an experimental browser platform by Mozilla. And things that turn up in Servo tend to turn up in Firefox eventually. There's soon, but maybe it's later. Just for now, it's just Chrome. And iOS. Wait, that can't be right. No, that's not right. No, it's not on iOS. Yeah, it's on iOS, but it's not Safari. It's called WebBLE for iOS. It's a browser specifically for Web Bluetooth, and it works, kinda. I wouldn't use it for browsing, well, daily browsing, but it works. And it's supported in Electron. It's supported in Node.js. It's supported in Cordova. Anybody uses Cordova? Wow. Yeah, me too, but don't tell anyone. And Esperino, which is really, really amazing. Esperino is a JavaScript interpreter that runs on small hardware chips. So this is 18 by 28 millimeters, small little chip. It has Bluetooth support, and it runs JavaScript. You can use this to create a Bluetooth device in JavaScript, or you can use it to control a Bluetooth device in JavaScript. And I'm going to show you a little bit about this in a moment. Now, I mentioned that not everybody supports standards. Well, this is some of the stuff I noticed. So, again, this is a light bulb. This is how we set a color and read a color from a light bulb. This is really, really simple, just 4 bytes, and each of those 4 bytes means something. But some other light bulbs are a little bit weird. You can't read the color here, but you can set it. And the order is GBR, which is a little unconventional. But fine. And you'll notice there's a 1, and then a green, then there's a 1, and a 0, and a 1, and a blue, and a 1, and a red, and a 1, and a 0. Those 1s are switches. If you set the 1 to a 0, it's going to turn off that LED. Because if you set it, the value, the intensity to 0, that's not enough, apparently. I don't know why. This is weird. This is weirder. So every byte here has to be exactly like this. Otherwise, it doesn't work. There's an RGB somewhere in there. There's some magic bytes. There's a random number in there because no two messages can be the same. So just add a random number. It was not my idea, or this is what the manufacturer does. And you have to calculate a checksum value to make sure that the message is actually correct, because Bluetooth, of course, doesn't support checksums in its network layer. Oh, wait, it does. So this is nonsense. But anyway, this works. I also have a little device. This is a pixel matrix, and it has 8 by 8 pixels. It's basically 8 by 8 is 265 light bulbs, and you give a position and an RGB value, and you send that to the device, and it changes the color of one of those LEDs. So this is pretty sane. And I also have another device. I don't have it with me. It's also pretty much the same thing. If you ignore this part. That is to change one of the LEDs on the device. Yeah, if this isn't documented, how you're going to figure this out? Yeah, we'll get back to that. How do you figure this out? Well, you can sniff the network on the Bluetooth networks. So you can figure out the messages between devices. So you use your app that the manufacturer created, and you connect it to the device. And you see all the network packets. And that works if you have a very old device, because nowadays that doesn't work anymore because traffic is encrypted. But there's a workaround for that. You use a phone, and you turn on developer mode, and you log all Bluetooth HCI packets on the phone itself. And then you transfer that to your computer, that log, and you can inspect it with Wireshark, and that works. And you can see what the manufacturer's application is sending. And that is really helpful. Now there's one other thing. If you can't figure it out using this method, there's always the possibility, and don't tell anyone, this is just between you and me, you can actually decompile APKs and see the source code that the manufacturer wrote and get inspired by that. That's really helpful. That is really helpful. So now, finally the fun part. At least I hope for you. For me, it's not so fun because hardware demos, they tend to go wrong, especially in times like this. At home it works, really. So this is experimental technology. This is just setting low expectations. This is experimental technology. It may not work. And there's Wi-Fi interference. Bluetooth and Wi-Fi use the same frequency. So, but we'll try anyway. So, here goes. I brought a light bulb with me. Let's turn it on. Nice little light bulb. Now, I can connect to that light bulb with a browser. Ooh. Yes, it works. Phew. Now, let's try changing some colors. Blue, green, yellow, purple, black. Yeah. Okay. White. It's not really white, but it's kind of whitish. The screen is wider than this. So let's try something else. What can we do with this? Let's see. We can use some CSS. Oop. CSS to change the color of a light bulb. So you heard about CSS in JavaScript. That is the controversial topic nowadays. How about CSS over Wi-Fi? Or CSS over Bluetooth? That is the next thing. We can turn it into navy, whatever. I can use any CSS I want. Even animations. Yeah, let's try that. Well. Oh, infinite. So we now have a rainbow animation on our light bulb using CSS animations over Bluetooth. So this is what sold me on this technology. This is just cool. Now, of course, I'm cheating because it isn't really running on the light bulb. It's running in the browser. And it's sending the colors that the browser calculates over Bluetooth to the device. But it's still pretty fun. Now, let's try something else. I mentioned a little matrix. Now, this is going to be maybe not really visible for the people in the back. But let's quickly try this. Now, I looked at the website and I love the pixel art on the Odessa.js website. I love pixel art. So this is what I do for fun. I draw pixel art on screens. For example, it works. It is a little bit slow. That is not because of web Bluetooth. It's because this device is just slow. And let's a little pixel art monster over Bluetooth. Now, is this already fun? Yeah? Well, I can make it a little bit more fun. I can drive around a car. How about that? I have a little Lego car here. Gonna turn it on. Connect to it. Gonna put it down on the desk here. Oh, this is really dangerous. My 5-year-old son will never forgive me if I crash this car. The most important part. Now, if I do crash this car, it's not because I don't like the Ukrainian flag. It's just because I'm a really bad driver. It works. Let's put it down on the stage. That is way safer. Now I'm just sending some bytes over Bluetooth to the device. That's all I do. I give instructions: turn left, turn right, forward, backward. So it's really simple. Backwards. Now, what else can we do with this? CSS animations. Yeah, seriously, CSS animations. We can do that. So I created some keyframes with a track and using CSS variables for directions, left, right, forward, reverse. And now I can remove this little dash and it starts driving on its own. I have to be really careful. Oh, there. We're okay. This works. Okay. Let's reset it. Let's go one step further. You notice the little Lego head here I have on stage with me. In it is a little device called a Nordic thingy, and on it is a really tiny switch. And that device has all kinds of sensors. Now, I connect to the device. It needs to stabilize for a second. There it goes. Now, if I pick it up, it follows exactly the movements I make on screen. I can use this to drive my car. So I connected two devices at the same time, and now well, it's a little counterintuitive. You have to go you have to lean backwards to go forwards. I'm getting really close to the edge of the stage. I'm going to stop. So you can connect to two devices at the same time and exchange messages between them. So the Lego head can't talk to the device on its own, but the computer, the browser, can relay messages. Now, I do have one final demo. And that demo is a little bit dangerous. But first, if anybody wants to try out this car, you can. If you have a modern Android phone with Chrome or Samsung Internet, and you go to a website called bluetooth.rocks. There are all the demos. And here is the racer. And you can actually connect to the device yourself. Please don't drive off the stage. Okay. Now for the dangerous final demo. I need to have safety glasses for that. Let's turn those safety glasses on. And now I can't see anything anymore. But that's fine, I'm just doing dangerous stuff, so that's warning, warning, danger. I can also use an equalizer just to visualize my voice. That is also pretty cool. But in this case, danger, danger. So what I'm going to do is, I mentioned drones, right? Yeah, in probably one of the first slides. I mentioned drones. I brought one with me. And I'm going to try to fly it here. It works. Just be careful. Just drive around whatever you want. Just be careful. I really can't see anything with these glasses. Just going to put them here. So I have a drone with me. And it's going to take a while to boot up. And then hopefully it's going to fly. Now, I know the people on the first row. This is actually dangerous. I'm sorry. I hope you're insured. So you'll notice there's a big button there. It's called emergency. Whenever the drone tends to fly into the audience, I push that big button. And then it will stop the motors and will fall on top of you. But at least the motors won't be spinning, so that's a good thing. So let's wait a second before it's ready to boot up. And try to connect to it. There it is. So, again, this is really dangerous. I have literally no idea what I'm doing here. I'm just sending some bytes to a device. That's all I do. And I just hope everything turns out okay. So let's try that. Oh. Okay, doesn't work. The thing with this demo is it always kind of fails on the first try, so I'm not nervous yet. So let's try it from here. Oh. There it is. And now I can... Oh. So all I'm doing here is using JavaScript to send some commands to this device. And I don't know how far I can go before it's out of range. I'm not going to try to fly it to the end of the hole, but this is pretty cool. I can do some tricks. Let's see that again. Whew. Are you getting nervous yet on the first row? I'll back away for a bit. Oh, this is... I'm trying to fly it, but the controls are turned around. This is really... let's... Yeah, okay. Whew. How am I doing on time?
A little bit late already.
Okay, no. Okay. Well, in that case, I have some other stuff I can show you. Just come to see me in the breaks during the conference. And if you have questions, also come up to me during the conference. I'm happy to answer them. And well, thank you for coming to see my talk.